Yeah.
Yeah. So what this question is that you will be given two coordinates from each rectangle. Like this is the coordinate of bottom left, and like x1 y1 and x2 y2 is the upper right corner. And there are two rectangles, and you need to uh, give the answer that if they overlap or not. Like if they overlap, you need to return true. So this is a question. Overlap means like if one of the rectangle is inside the another rectangle or covering half of the rectangle, which is called an overlap. And one more thing, it is also mentioned that uh, that two rectangles that only touch at the corner or edges do not have overlap. Like if they have if they are on a like if their coordinates are equal as well, like other coordinates to another rectangle or coordinates, then also they are not overlapping. Like if x1 of one rectangle is 1, another also x1 is 1, then it's not overlap. No, x2 of, yeah. So yeah, anybody has tried this question, wants to discuss their approach, please welcome. Anyone? Anyone wants to have tried this? Any brute
Yeah,
force?
yeah, I tried it. So it was pretty simple. Like we just have to check if one rectangle is overlapping other by just checking that one rectangle is like on the right of that rectangle, on the left, or the above or below. If this four condition happens, then they does not overlap. Else it will overlap.
Yeah, I have also worked on this approach. Even I have written the code on this one only. So, which
Okay.
is basically checking the condition of if they are not overlapping, which is true. Otherwise, it will be false. And like they'll be. Otherwise, it would be true. So, anyone else can share any different approach?
My approach is to reduce it to a single, a single dimension. To say, suppose we have two lines, and to see that two lines overlap or not, because the rectangle is like two dimension, right? So we should check, both the horizontal dimension if that overlap, or the vertical dimension is overlap. So kind of reduce it to a single line.
So you are making a single line of all the coordinates, or just the first coordinates of both the rectangles and the second coordinates of both the rectangles in the different lines?
Yes. Yeah, but let me see. Yeah, because the the coordinate of the the x, I mean the coordinate of x first, and then the coordinate of y.
Mm-hmm. So can you explain with this first example, how did you make it a single line?
So the rectangle is two. I think rectangle is four lines, right? Two lines are parallel.
Mm-hmm.
Okay. So I'm thinking of to see if that two lines are overlap. I haven't worked it out yet, but that's just on my mind.
Okay, so you are saying if we can make them into a single line, so if one of the coordinates is in that particular, in between that particular first rectangle or like near about, then it's overlap.
Yeah, if the horizontal line are not overlap, then it's not overlap, right? But if the horizontal line are overlap, then we have to check if the vertical line are overlap.
Okay. Yeah, that's also sounds interesting. I haven't heard about that. Like, think about this kind of thing. We can try somehow. Anybody else who wants to share any thoughts on this
Uh,
particular?
One approach that I tried was like find the center of both the rectangles and the distance between both those rectangles. Like the distance should be like less than the sum of half of length of one side if they are to overlap on the x-axis. So the distance between the center of two rectangles will be like half of length of one rectangle plus half of length of the second rectangle. Like if the distance is greater than this, then they are not overlapping on the x-axis. Similarly, the distance between the centers is less than like the half of the breadth of first rectangle and half of the breadth of second rectangle, then they're overlapping.
Interesting.
Yeah, that's interesting. Can you explain on the whiteboard or
Just a second.
hello?
Yeah.
Do you want to explain on the whiteboard your approach? That sounds very interesting.
Can you just draw? I don't have actually a laptop with me right now, but if you'll draw with me, I'll show you. Like I'll kind of walk you through with it, so that others can also visualize it. If
Sure.
that's okay.
Let me share. Okay. Can you see the whiteboard?
Yeah.
Okay. So we have a rectangle. Sorry,
Yeah.
I'm bad at this. So like we have a rectangle of one rectangle
Yeah. This.
and its coordinates are like 0 and 0. And this is 2 and 2.
Yeah.
Yeah. So you are finding the midpoint of this this
Yeah.
particular point. Okay,
Yeah.
so we have a midpoint like maybe 1, 1.
Yeah. 1, 1 will be the midpoint of this rectangle,
Yeah.
and similarly the length is 2 and the height is also 2, right? So it's kind of a square only.
So yeah, it's kind of a
Yeah.
square.
Yeah. Similarly, if any other rectangle is to overlap, so if the distance from 1, 1, right? So let's say
It's distance
just
from 1,
take
1 to
the center of this rectangle.
okay to this rectangle.
Yeah, center of this rectangle.
Okay, let it be something. And others are like 2, 2. This is center is 2, 2 because we have coordinates of 1 and 1 and 3 and 3. Somewhere like that.
Yeah, it's not an actual representation, right?
Yeah,
Because
yeah.
if this is it's on 2, 2, then the center would coincide with the top right corner of this rectangle. Anyways, I'll explain this. Okay, for these, let's take a case when it's just overlapping on the x-axis. Okay, so if the rectangle first is on 0, 0, right? And its length is 2. And to just overlap, so the second rectangle must be, if it's just touching the side on the x-axis, it should be on starting from 2 2, and the length would be anything, right? So to just overlap, the length will be 1 plus the half of the length of the second rectangle. If the distance reduces from that, right, so it will come inside the rectangle from the, like, because distance is a squared product, right? So it can overlap from any distance. Like if you just take one example from the problem, I'll explain it with that. Okay, so
Yeah.
it's clear.
Yeah, it's you can explain, like it's a, we have a coordinates of 0 0 2 2 and 1 1 and 3 3.
Yeah, so so on 0 0, right, and 2 2, its center is 1 1, and from 1 1 and 3 3, its center will be 2 comma 2,
Yeah.
right? So the unit distance of from 1 comma 1, that is the center of the first rectangle, to 2 comma 2 is like 1 square plus 1 square 2 under root 2.
Yeah.
Yeah, under root 2 should be less than 1 plus 1, which is the half of the length of both, right? So
Yeah.
under root 2 is less than half of the length of one rectangle plus half of the length of other rectangle. So we know that they are overlapping on the x-axis. Now to confirm that they're also overlapping on the y-axis, we'll do the similar thing. The distance between the two centers should be half of the, like, breadth of the first rectangle and second rectangle. Like if you draw it to a scale, then you'll be able to visualize it, like when you push the
Yeah,
rectangle.
got it. Yes, yes, correct. Uh, yeah, that's a great approach. Anybody have anybody wants to, anybody have doubt about this particular approach? So it seems like this is a good approach. And what's the complexity for this particular thing?
So this is like a constant, like you're just doing just calculations only. So
Yeah.
the main complexity is like how the square root is implemented in the language, because like the distance between two points you can easily find by the distance formula. So that's x2 minus x1 plus y2 minus y1, like squared and under root. So the main complexity comes like that is, I guess, I don't know, it's a constant only in most languages, but if we're really going into details, so I think it would be a log
Yeah, the
complex.
complexity, I think in this particular problem, we know the coordinates. We just need to do some
Yeah,
calculation to find out the, I
yeah.
think
So
there is no memory issue and no, I think we are not taking any, in all the approaches, I think the other approach also,
yeah,
it's not taking.
everything would be constant only. Yeah.
Yeah.
One one thing that
It would be
this
log and I
problem.
guess, because we are calculating the square root, and square root costs log and time complexity. What I think.
Sorry?
Yeah, one thing I can see, it could be have this could be error in this problem is because it could produce the floating point, right? And with the floating point, when it go into like precision, so the distance is very very close. We might not be we might think it overlap, but it not overlap.
That's a good point.
Yeah. Uh, did you try, Ronak, for any other, like, if their coordinates are matching or some other test case?
Actually, it passed on Leetcode, so that's why I thought about this, because this is kind of like how we detect collisions between rectangles in games. Like, so that's how I got the idea. But yeah, I agree with the floating point error, but because those are like, if like it's on the only very like very uncommon in cases of irrational numbers only, when the floating point is actually rounded off. So in that case only it was, I think the input size was also not that constrained, I guess. So this approach worked, I guess. That's why.
Mm-hmm. Okay.
You can also just compare the square of your, don't convert into a square root. Just
Yeah,
convert the
yeah,
other side.
yeah. We can avoid that problem as well. Like we can just square the distance, and then we can get rid of getting the square. So
Yeah.
Yeah, just be careful of out of bound. Like, maybe your integer now is not able to hold that. I don't know the test case, but if you handle that, then this will work.
Yeah, that would work.
so you can
And
also you can modify this approach to just find the distance. Like it can be like if you find the center point of both the rectangles, you can find the distance, because we're checking only on the x-axis for the current. You don't actually need the distance vector. You can just find the distance on the x-axis, and that distance should be less. That this property holds that then also. Like if the distance between the two centers on the x-axis is less than half, like because when you're trying to move the second rectangle away from the first one, so the distance is only increasing on the x-axis, right? If you're separating it on the x-axis, so you can just find like center of x2 minus x1. That will also work on the x-axis distance. You don't need the actual distance vector also to calculate overlaps on individual axes, which the approach, I guess somebody was discussing before me, like to convert it into a single dimension. So
mm-hmm.
if I just consider the length side of two rectangles, so when would these two line segments overlap is when the center from one line segment, and which the approach the guy before me just described, is that the center of one line and the center of other line, the distance between those two lines is reduced by half of length. If you see, like when are these two lines just touching, is this when, let's say this line is of unit length 3, this line is of unit length 2, right? So if they are just touching when they have total length of 5, right? uh Hello.
Yeah.
Yeah, I think, was that clear, like how I like connected it with the first guy's approach, right? On the single line, how you check overlap. Like
Yeah.
let's just draw a line segment of, let's say, unit length 2 and 2. When would these overlap? When the distance between those two line segment is less than 2, right? Center. If that's okay. Well, on each axis you can do that to find if they overlap.
But that would be a long approach, I would say, to check
No,
on
it's a,
the.
so you need to find overlap in both the axes, then only they overlap. You like, that's the point, right? But then you get rid of all those cases, like whether like it's from the left hand side overlapping, or from it's overlapping from the top or bottom. So you check just on the x-axis. Let's say I'll give an example with this only, no? So let's
Mhm.
say, if let's say on the x-axis, let's just consider the length part of it. So it's from 0 to 2. One line segment is from 0 to 2, and one
Mhm.
line segment is from 1 to 3, right? Let's
Two,
now
three.
move. Yeah, so the midpoint of first line segment is 1, and the midpoint of second line segment is 2. Now if we try to separate these two line segments, just let's say I just move the one line segment from 1 to 2, right? So the total length would be from 0 to 4, right? So are you getting
Mhm.
why we are taking half of the first length of line segment and the half of second line segment? So by this we will be able to figure out that they overlap on the length axis, like x-axis in this case, and similarly we can do for the y-axis.
Yeah, I
Okay.
think that's a clean approach.
Yeah.
The
Okay.
single,
Yeah. So that sounds to change and
Yeah, and
simple approach.
and you won't have floating point errors as well on this one.
yeah, taking the center would be, cleaner. Because normally I just I compare the minimum of endpoint and the maximum of, the minimum of endpoint and the maximum of start position, and see if it overlap. But I think this using the center would be easier.
Yeah, that's another approach of finding the minimum on the upper coordinates, minimum and the maximum from both the coordinates, and then getting an answer. So yeah, seems like we have good